Welcome. This is the next module in the lab orientation part of the microfabrication course. If you remember correctly, in one of our previous modules, we have looked at general how microfluidic devices looks like, and what is a peristaltic pump, what are the different kinds of pumps used, peristaltic and syringe pumps we had discussed. Then like how to load samples into the pump, how to flow liquids. So those things we had discussed. So that time I had shown you in the microfluidic device channels, certain patterns, and how liquid will be flowing through that. But then how are these patterns made? How are these micro channels made? So microfabrication processes will be used to make these channels. That is why the use of microfluidic devices becomes relevant to the scope of this course. So today in this module, this will be an extended module. Today in this module, we will run you through a very important portion or a part of a microfluidic channel fabrication, which is PDMS molding. So what we will do is, we have a master or a mold, a master mold which we have fabricated with silicon, and on using that master mold, we will be pouring PDMS, curing it and making channels out of it. So that whole process we will show it to you. What is PDMS? PDMS is polydimethylserine. So it is a form of silicon that is very transparent once it is cured. In its native normal room temperature form, it is a thick viscous fluid, and once we do subject it to a certain set of heating processes, along with adding something called a curing agent, that PDMS viscous liquid solidifies to a rubbery, elastic but solid transparent membrane, which is very good for making microfluidic channels. So the channels will be engraved on this PDMS membrane, and that membrane we can stick onto another substrate that might have a sensor like an electrode, or even stick it onto a glass slide, inside which we can flow the liquids. So this is the overall idea. So today, as I told, we will be actually doing the silicon PDMS molding using a silicon master. What is a master? Master is a mold which has the patterns on it, which will form the negative structures on the PDMS mold. So let us see what is the pattern we are trying to make. So I have with me here a silicon mold. Can you see the pattern on its surface? So as I told, this is the silicon master we will be using to make the microfluidic channels. As you can see, the channel dimensions are embossed on the silicon wafer. How was this silicon master made? So we took a normal silicon wafer, p-type silicon wafer, which usual silicon wafer dimensions are around 500 microns thickness. Then we deposited oxide layer on top. After that, what we did is, we did photolithography of the pattern of this pattern. These are the microfluidic channels. Now they are coming as elevated structures. These will come as channels on the PDMS, because negative of this will form on the PDMS. On top of this only we will pour PDMS. As we told, so silicon wafer we will take. The silicon wafer is around 500 microns in thickness. Then we will have an oxide layer on top. Then we will do photolithography. We will pattern the surface of this wafer using photolithography, so that we will get this pattern. Then we will remove the photoresist after developing it. After developing it, we will have the pattern formed on the surface of the wafer. Then what we will do, we have to do something called deep reactive ion etching. So wherever the pattern is not supposed to be there, we will etch away the silicon material, so that only the pattern remains as an embossed structure on top. The process we use is what? Deep reactive ion etching. I think reactive ion etching you would have covered in the theory, or if not, you will be covering it. So reactive ion etching is used, and then it will etch out the pattern like this on the silicon wafer surface. Once that is done, we will remove the photoresist from the rest of the wafer, and then yes, we will have the silicon master mold with us. Once this mold is ready with us, we are good to go to do PDMS molding. Today we will be doing PDMS molding basically of this channel on the PDMS membrane. So, for this we have made this setup for the experiment. So, what all things do we need? So, this is PDMS, it will be a highly viscous liquid. So, see silicon elastomer, that is what it is generally called. It is called silicon elastomer, that is what is generally called. So, it is basically PDMS. It's a 1 kg bottle, we will use very less quantity of that, around 50 ml. Then this is the curing agent. So, this is another chemical. So, this curing agent is what will make the PDMS become solid after sufficient time. So, we have to mix PDMS and curing agent in 1:10 ratio. So, 1 part of curing agent and 10 parts of PDMS, that is the usual mixing ratio. Once we do that, once we mix it, we have to stir it continuously for 10 minutes so that they get mixed properly. In the stirring process, lot of air bubbles will be formed in the mixture, but air bubbles should not be there in our membrane because we need it to be a very clear transparent membrane. Then what we will do, this mixture we will keep inside a desiccator unit and depressurize it so that all the air bubbles will start coming out. Once that process completes, that will need around 20-25 minutes. Once that process completes, we will get a very clear liquid of the PDMS clearing agent, curing agent mix. Once that mix is ready, we will take that mix and pour it on a petri dish that is containing our silicon master. Once that is ready, we will have a dish containing the PDMS and curing agent mix with the silicon master at the bottom. That dish, then we will keep it at around 60 to 70 degrees Celsius for 2 to 3 hours inside the oven. Then it will, after that, if you take it out, we will see that the PDMS has become cured and it has become a solid layer. Then whatever dimensions we need, we can cut out that PDMS from it. This is the overall process which we will be showing it to you today. So, what all things do we have? What all equipment do we have? We have our silicon master, which is in a wafer carrier. We have a 135 mm glass petri dish where we will keep our silicon master. We have a SS or stainless steel tweezer to handle our wafer. We have a stirrer. This stirrer is used to thoroughly mix the PDMS and the curing agent. 50 ml tube where we can mix the PDMS and the curing agent before we pour it onto the petri dish. And we also have a 15 ml tube for in case we need it during the process. And obviously, we have the PDMS and the curing agent with us. So, these are the major things that we need for doing this experiment. At the end of the experiment, you will be able to see a PDMS membrane clearly getting formed. So, we have taken 50 ml of PDMS here, 50 ml PDMS and 5 ml of curing agent. Now, we will mix it in this petri dish. So, first let me add the PDMS. So, if you see closely observe, you will see that it is a very viscous chemical. It is basically another form of silicon. So, if you can see the petri dish, you will see that lot of air bubbles have formed in this. So, we have to have a proper process to remove the air bubbles, otherwise this air bubble will form artifacts in the final PDMS layer that will be formed using the silicon master. So, that is why we will be using the desiccator which I explained before. So, I am just waiting for the whole PDMS to get poured because we have measured 50 ml. So, let us maximum from the tube go to the petri dish. So, if you just I will just still the petri dish, if you see it, you will see lot of air bubbles in it. So, these air bubbles have to be removed at some point. Now, we are adding the 5 ml curing agent to this mixture. So, we have added 5 ml curing agent. Now, we have to mix it thoroughly as we have discussed. So, we use a glass stirrer. Why are we using glass? Glass is a very inert material, so it will not react with the chemicals. That is why most of these equipment like petri dishes and all are made of glass. This is a very general knowledge, but then many people don't know that. So that's why we are discussing that. So we are using a glass stirrer, as you can see. So with the glass stirrer, we have to thoroughly stir the PDMS and curing agent. So I am stirring it. See, this is how we should stir it. We should stir it for almost 10 minutes. So we have now thoroughly mixed the PDMS and curing agent for 10 minutes, more than 10 minutes actually. You can see the mix now. It is full of bubbles. You cannot use it directly. Actually, this is the mix we need to make the mold, but then with these bubbles, this is the same layer that will form as a thick solid once we cure it. But then lot of bubbles are there inside, which is not desirable. We need to remove all the bubbles. So we have thoroughly mixed the PDMS and curing agent for 10 minutes, and the mix is now ready. But then as you can see very clearly that the mix has lot of air bubbles in it. Lot of air bubbles, which is not desirable, because this is a mix that we have to pour on our silicon master, and once it becomes solid, these air bubbles, if they are there, no, they will form part of the layer. Then it will not be transparent and we will not be able to see what is beneath. The channels will be formed at the bottom of this membrane, effectively the membrane that will be formed. So it is very important that this liquid mix, fluid mix should be free of air bubbles. So the next process is to remove the air bubbles from this mixture. How do we do that? We do that using a vacuum desiccator and a vacuum pump. We have already seen in prior modules how the vacuum desiccator and the vacuum pump are used. Now we will see the actual practical application of it. What we will do now is we will keep this dish inside the desiccator. So I am opening the lid of the desiccator. Now we will keep this dish inside the desiccator. Okay, now we have kept the dish inside the desiccator. We are closing the lid. Now we will connect our vacuum pump to the inlet of the desiccator and now we will switch on our vacuum pump. So just now we saw the air bubbles. See, air bubbles are accumulating at the top of the you have seen as a close-up videos grab where the air bubbles are accumulating at the top of the dish. All the air bubbles are coming out. So as and when all the air bubbles come out, it will become a clear solution. So it will take around 25 to 30 minutes to remove all the air bubbles from the mixture. So we have taken 5 ml of the curing agent in this tube. Now we have to mix this first in another tube. So as I told, we will be adding PDMS and curing agent and PDMS in 1:10 ratio. That is 1 part of curing agent and 10 parts of PDMS. So because we have added 5 ml of curing agent, we have to add 50 ml of PDMS. So now right now he is adding 50 ml of curing agent. So now we have desiccated it for almost 15 minutes to remove the air bubbles. What we have done, we have kept the PDMS curing agent thoroughly mixed. It had lot of air bubbles in it. We kept it inside the desiccator and we are trying to suck out air and create vacuum inside the desiccator. In that process, what happens, whatever air bubble is embedded within the liquid, it comes to the surface because it is getting pulled by the environment. So all the air bubbles will first come to the surface. They form a thick air bubble area, like when you open a fizz drink, a carbonated drink bottle. When you open, you will see all the bubbles coming to the surface, right? Like that, these bubbles will come to the surface, and again as and when we still continue taking air out of the desiccator, these bubbles will start escaping from the surface. So over time, all the bubbles will escape from the liquid, from the bulk of the liquid and from the surface of the liquid, and eventually the liquid will become very clear. Now we will take out the liquid and see how clear it is. So we have switched off the desiccator. Now we cannot directly take out because it will create a shock inside, and the petri dish may vibrate or get thrown away inside because there is no air actually inside. So we are slowly recreating, we are depressurizing, we are removing the vacuum inside. So now air is rushing back into the desiccator. Once that is done, we are removing the desiccator. Now we will see how clear the liquid has become. We are taking it out. Now see, it is very clear now. It's a very clear liquid. You cannot even see whether the liquid is there inside. That it is that clear. Now this clear liquid we have to pour on top of our mold. So we have the mold here. We have put it in a petri dish. Now we have to pour our PDMS curing agent mix on top of the mold.
Try to focus there. Only there.
So as and when we pour, more air bubbles are getting formed. So we have to do one more level of desiccation to remove the air bubbles in the second round of pouring the PDMS onto the mold. So we are pouring the PDMS onto the mold. This process also creates air bubbles. So now we have fully poured. I cannot tilt it and show you because it will affect the surface profile of the PDMS. So now we have poured the PDMS on the mold. It is evenly distributed, but there still it has formed few air bubbles. Now we have to do the desiccation process again with the PDMS on the silicon mold, and then remove these air bubbles also. So this one I am taking it, putting it again back inside the desiccator. I will put the desiccator back into view for you. Now we have put the PDMS and the silicon mold. So we have kept the petri dish with the PDMS curing agent mix. After removing air bubbles, we have put it on the mold. Now the mold, PDMS, everything is there. We have to again, while in the process of pouring the PDMS on the mold, some air bubbles got formed. So now we are again closing it. So with these air bubbles also we have to remove. Now these air bubbles also we have to remove now. So what we will do, we will again desiccate it. Now this process is very clear to you. We have to desiccate it now. We have connected the pump. Now we are taking out air from it. So this will remove the air bubbles second time. Like last time there were millions of air bubbles actually inside. Now it is few hundreds. So these air bubbles won't take much time to clear. So maybe around 5 minutes it will take, and these air bubbles will get cleared, and again we will get a very clear solution on top of the silicon mold. So now we have performed the second round of desiccation for almost 10 minutes to remove the air bubbles that were formed again when we poured PDMS on the silicon master. So now we have desiccated it. Most of the air bubbles around the device is gone, and we have got a clear layer of PDMS on top of our silicon master. So this is what we are having. So we have this much thick layer of PDMS on top of the silicon master. Because it is so clear now, you will not be able to even make out that there is a liquid on top of the master. But actually the PDMS curing agent mix is there on top of it. Okay. Now the next step is to cure it. What do you mean by curing it? We have to keep this at around 70 degrees Celsius for a couple of hours, 2 to 3 hours. Though that the PDMS will solidify, it will undergo a chemical change where so that the physical properties will change and it will become a solid rubbery material which we can stick onto another surface like a silicon wafer or a glass slide. So let's keep this inside the oven. So the operation of the oven also we have shown you before. So we have set the temperature of the oven to 70 degrees Celsius. So we will keep the glass slide in the oven. So we have kept it inside. This is for the curing process. After keeping it inside, we are closing the door. Now we have to leave this for around 2 hours. After that, we will take it out and see how the PDMS layer has been formed. So we have we had prepared PDMS and the curing agent. Air bubbles were there. We removed the air bubbles 2 times. First, when we had prepared the PDMS with the curing agent. First, removed the air bubbles with the mixture. Then we had poured PDMS onto the mold, silicon mold, and removed air bubbles from there also using a desiccator. Then we had kept it in the oven for the curing process. So it has been inside the oven for the last 2.5 hours now. By now it would have cured properly. Now we will take out the petri dish that contains the silicon mold and the PDMS on top and see how it has come. So this is the petri dish with the silicon mold and the PDMS. So now if you might not be able to see because the PDMS has formed a very clear surface on top of the mold. It is almost like glass and you are not able to distinguish which is the glass bottom, petri dish bottom surface and which is the PDMS surface. Now next step is to cut out the PDMS membrane with the pattern with the required size that we need, and remaining area also has a PDMS which we can cut it out also to see how PDMS has got formed. So first we will cut out from a normal area which is not under the mold pattern and show you how PDMS after curing looks like, and then after that we will. So for cutting out the PDMS from the glass petri dish, the main things that we need are a very sharp knife so that we can make fine features on the PDMS membrane, and a metal scale. You need a metal scale because the cutter should not cut out the plastic if it is a plastic scale. A metal scale to take your measurements, steel tweezers so that you can peel off the PDMS membrane from the glass slide, and finally you need to have aluminum foils because once the mold is formed, the mold gets stuck onto your glass plate, so that you have to reuse your mold. To reuse your mold, you have to cover your petri dish with aluminum foil or some sealing material so that you can reuse it. Otherwise, a lot of dust will get settled on top of the mold and it becomes non-reusable. So let's see how we can cut out. Now we will cut out PDMS from an outer area, not from top of the mold, to show you how after molding the PDMS membrane looks like. I am left-handed today. So we are trying to peel off the whole membrane, so we are taking it out from the edges. So you can see the membrane getting peeled off. So we are making a boundary around the petri dish so that the whole membrane we can take out. See, we are covering the edges. The mold is in one part of the. So now we will try to peel it off. So you can see, you can slowly see now the membrane. See, it is very clearly visible. It's a very transparent membrane, and we are peeling it off now. See, it is very transparent but flexible also. It is like glass but flexible. It's like flexible glass. We have to be very careful around the mold, because the mold will get stuck onto the bottom of the dish. So till the mold we will take out, and then try to see how we can take out the PDMS around the mold separately. So we have removed PDMS from around the wafer. So this is how the PDMS after curing looks like. So see, this is how the this is a PDMS that was formed around the silicon mold. See how flexible it is. So preferably you should hold it either with a gloves or tweezer. Please never hold it with your bare hands. So this is how the PDMS will look like. It's flexible and fully transparent. See the thickness. This is how thick it will be, and it will be flexible. Now we have our core area we have to do. We have to peel off the PDMS on the surface of this silicon mold. You see the pattern here. So the pattern is here. So we need to take the PDMS below this pattern. So that's what we are going to do. Let's do the peeling off process. So we have to be very careful while doing this. So slowly we are taking it out. Then somebody should parallelly hold the dish, because it is glass, it should not slip, and then slowly take it out. So now we have cut across the PDMS membrane around the mold, and we are now taking it out, as you can see. So the pattern is there. I think very clearly your pattern is visible here. So see, the pattern has been formed. The pattern that is there on the silicon master has formed on the membrane. Now we will see the membrane's other side to see that the pattern is formed. Yeah, see, against my, yeah, you can see the pattern here. The pattern has very nicely got formed on the PDMS membrane, and it will be a channel. Here it will be a ridge in the wafer, and on the wafer it will be a ridge here, and on the membrane it is a channel. This is how we make PDMS based microfluidic channels. The next task is to cut out the device with our required dimensions that we can do with a knife, and then we can cut it out with whatever dimension we need. Because now this membrane is circular. Now the membrane is circular, but we need to make a rectangular shape out of this membrane. So that is the next final task. And then once that is done, we can store this device. Now this is also a device. This PDMS membrane is a device which we can stick onto an electrode or a glass slide. So we have to cut it out to a required shape and store it in aluminum foil or any other storing material. So now we are cutting the channels into a rectangular shape. We have already made a cut here to remove this piece, and now we will be making another side of the device. The device is here, and we are going to cut it out. So another dimension we have made. Once the membrane is ready and it is successfully removed from the master, it is a relatively easier task to cut it out. But remember, always be very careful with your silicon master. It is a very expensive piece of device that we have made. So, and once you have peeled off your PDMS membrane, then it is okay. You can just cut it out to your required dimension. So now we have made all 4 directions. With a metal scale we have cut. Now we will remove the extra material around that square rectangular portion. Yes, that is removed. Now we have peeled off the extra PDMS membrane and made a rectangular portion for our device. Don't make sure that you don't reach with your tweezer to your device area. Keep it far away from it, and you can see that device. You can see the device also here in this region against white background. No, against black background. No.
Pure white na.
Yeah.
So glass very.
So anyway, you might have seen the device. Yeah, you can see the device here. Now, yes, that is the device. So make sure that you don't contaminate it with air. So we have to quickly pack it off in aluminum foil and store it for use. So we'll put it in an aluminum foil and then we will store it for use. So people, so students, I think now you have got a very good idea of how using a silicon master, microfabricated silicon master, you can make a good, nice, thick PDMS membrane like this with your micro channel in it. So this is a very important process in microfluidics fabrication, and it is very important that you know each and every single step and the importance and purpose of each of these steps in the whole process. So once the medium membrane is ready, as I have told, you can stick it onto a glass slide or a silicon wafer that may or may not have sensors. They may have electrodes, or they might be pure optical analysis based devices. So how do we bond PDMS membrane to glass? So that is done through a method called oxygen plasma bonding. So we have fabricated the PDMS mold, as you have seen. So you have understood the whole process, as I just explained, that how important each process is. So once the membrane or the channels are ready in the PDMS, we can bond or stick. Stick is the colloquial word. If you are working in a technical field, so you should use the technical term. So that is bonding. You need to bond your PDMS membrane with a substrate. That the substrate might have sensors, which may be electrodes, heaters, or any other metal or material that might be deposited on your substrate, or it might be a very clean glass slide also, and your device might work on optical measurement basis alone. So you can bond your PDMS with glass or with, say, a silicon wafer. So here we have a glass slide with gold electrodes patterned on it using photolithography. Are you able to see clearly? So this is a glass slide with, so this is a glass slide where we have patterned gold electrodes using photolithography. So what we will do, we have to first clean the glass slide properly so that there are no contaminants. Then we have to coat it with gold, okay, so that you can use methods like sputtering, which you have learnt in the theory. You sputter a fixed the thickness of gold on the glass slide, then you pattern it after doing PR coating and then exposure using a mask aligner or a general photolithography machine, and then you form your pattern, then you will expose it. Then once your pattern is formed, you will etch off the remaining gold using a gold etchant like KI. So then finally you will have your gold electrode. On this gold electrode, you can bond your microfluidic channels. So make sure that you don't touch the device. So like this, you can bond your microfluidic channel with your electrodes, aligning your channel with the electrodes. Once that bonding is done, your device is ready. Especially a microfluidic device will be ready. How do we bond it? Bonding is done through a method called oxygen plasma. So we are not going to the details of how that is done, but this is how bonding is done. Similarly, bonding can also be done to silicon wafer. So next is we have another glass slide. This is a heater that is patterned using nickel. So similar methods, you first coat nickel, like deposit nickel, and then you pattern it using photolithography, and then again you can use microfluidic channels on top of this nickel electrodes. So this is not an electrode, this is a heater. It is still an electrode, but the construction is different. Its purpose is to just heat to a particular temperature, so that if you have biological experiments, you can maintain your samples at a particular temperature. So hope you got an overall wholesome idea of how a microfluidic device will be fabricated, how microfluidic channels are made, how electrodes are patterned on glass or silicon wafers, then how do you bond it. So, hope you have got a good idea of the whole process, like the way you have learned in theory, you have seen it in practice being fabricated in our lab series. Hope this was useful to you. Thank you.